Hello friends, in this video we will be talking about electromagnet. Now, to start with, we know that every current carrying wire has a magnetic field around it. हर current carrying wire के आसपास में अपनी एक खुद की magnetic field होती है, अपनी एक खुद की magnetic field lines होती हैं. Suppose if I have this current carrying wire which is carrying current I, then there will be magnetic fields surrounding this wire. But this is a very weak magnetic field. What I will do to make the magnetic field stronger? I will take the wire and wound the wire around a cylindrical frame. What I will do? I will take that wire and wound that wire around a cylindrical frame. So what will happen? That these ends of the wire, they will now come closer like this, right? Current goes like this, then like this, then like this, and then it goes away from the loop. So what will happen? The magnetic field lines that were present at the top and the magnetic field lines that were present at the bottom, these and these two magnetic field lines will come close together and they will be forming a very strong magnetic field. All right, because the magnetic field lines will come close together, the magnetic field will become strong. This is a comparatively weaker magnetic field, right? But even this magnetic field is not very strong. What I have to do? I have to even make the magnetic field stronger. इससे भी ज़्यादा strong magnetic field बनानी है. तो for that purpose, not one single loop of current, but many different loops of current will be formed, like shown in this circuit, right? Lots and lots of windings are there in this, and this type of circuit is known as a solenoid. What it is known as? It is known as a solenoid. When the key is turned on, the current starts to pass through this solenoid and magnetic field starts developing inside it. The magnetic field consists of magnetic field lines, so there will be many magnetic field lines, okay, and those magnetic field lines will be existing at the top, even at the bottom of the solenoid, and hence the magnetic field becomes extremely strong. How much strong? The magnetic field of this solenoid or this electromagnet are very much similar to the magnetic field of a bar magnet. ऐसा करने से जो इलेक्ट्रिक फील्ड हमें मिलती है वो आप हमेशा कंपेयर कर सकते हो with the magnetic field of a bar magnet. Okay, here also the field lines are like this. Okay. Now for a solenoid, on what factors does the strength of magnetic field depends? Magnetic field is represented by the symbol B. It is because of a name of a scientist whose name was Biot, and he did a very good amount of research in case of magnetism. So we attribute the sign of magnetic field to his name B, such as the unit of force is Newton, the symbol is capital N. Similarly, the symbol of magnetic field is B and the unit of magnetic field is given as Tesla. Okay, another scientist. Tesla, every one of you have heard about. Okay, so let us talk about on what factors does the strength of this magnetic field depends. The strength depends on capital N, that is the number of turns and the current passing through these turns. That means if I have 10 number of turns in one solenoid and 100 number of turns in another solenoid, which of the magnetic fields will be stronger? This will have a stronger magnetic field because the number of turns are more and magnetic field is directly related to number of turns. Okay, in one of the solenoid, if I pass 5 ampere current and in another solenoid I am passing 7 ampere current, then which magnetic field will be stronger? Because B is directly proportional to current. That means more will be the current, more will be the magnetic field. So obviously magnetic field will be greater for a 7 ampere current. Greater is the current, greater is the magnetic field. And the last factor comes, that is L, that is the length of solenoid. What is it? It is the length of solenoid. So if I have one solenoid of length 10 centimeters and another solenoid of length 20 centimeter, then please look into this. Magnetic field is inversely related to the length. That means smaller is the length, greater will be the magnetic field. Okay, so out of two solenoids of 10 centimeter and 20 centimeter, smaller length wala solenoid, that means this solenoid will have greater magnetic field. Now this N upon L, what is N? Number of turns. And what is L? The length of solenoid. It can be written by a simple alphabet, small n. What is small n? Small n is known as turn density. Nothing related to mass upon volume, but this N is known as turn density. Let me explain what is turn density. See, if I have a solenoid and I have some wire over here, ठीक है, अब मैं इस solenoid के ऊपर ये wire को ऐसे wound करता हूँ, ठीक है, और 1 सेंटीमीटर की distance पे, ठीक है, I will just draw it and show that if I have this solenoid, एक तो cylindrical hollow cylinder लेना है और उसके बाद में I have to wind some copper wires on it and I'm winding like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many total number of turns are there? 10 number of turns are there. I am winding it like this. And in another solenoid, I am winding it in a little different manner, that is one over the other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Turn density means total number of turns upon length. So what is the length of this solenoid? It is from here to here. This is the length of solenoid. In this solenoid, the length is less. Okay. So total number of turns per length. Here the number of turns are 10 and the distance is 10 centimeter. Here the total number of turns are 10, but the distance up to which they are spread is, say, suppose 3 centimeters only. So this is what? The turn density, and it is equals to 1. Here the turn density is equals to 3.3. So where is the turn density more? In this solenoid the turn density is more. So in order to create मैग्नेटिक फील्ड्स, एक्सट्रीमली हाई मैग्नेटिक फील्ड्स, वायर को दूर दूर वाउंड ना करके हम एकदम पास पास में वाउंड करेंगे या एक वाइंडिंग के ऊपर दूसरी वाइंडिंग करेंगे. जैसे आप वो चलाते हो ना, फिरकी पकड़ते हो, तो उसमें कैसे वाइंडिंग होती है, ठीक है, द थ्रेड इज वाउंड once and then it again wounds second time over it, so the turn density increases. All right, so the total turn density, the total magnetic field of this solenoid depends basically on two factors. It is directly proportional to turn density and it is directly proportional to current. And please remember that the magnetic field of a solenoid is very much similar to the magnetic field of a bar magnet.